All right, thanks for that. That was fun. Now as I catch my breath. So, you like it? You like the costume?
Yeah.
Rock and roll, yeah. You gotta, I mean, you know, make sure you're able to return it after. All right, Jen, in the frame there, head, top of the head, everything. Actually, can you tell?
Yeah.
We're good? Okay, great. Okay, today's lesson on statistics is on the standard normal distribution or standard normal curve. It's actually pretty intuitive. I think you'll like it. Just feel free to ask any questions you have. I need that peanut butter after. Need protein. Oh, I forgot my dumbbells at home. That'd be fun. Just like little 2-pounders. Anyway, standard normal curve. It's pretty straightforward. Just ask questions because it's weird at first, but then hopefully you'll get it. Okay? So we've been introduced to the normal curve already. So let's actually just draw one maybe on the side of your paper somewhere. What goes in the middle of the normal curve?
0.
Okay, good job. Here it's 0. Here it's 0. But what in general happens in the middle of the normal?
Mean.
The mean, which is the average. Okay? So here we have the mean. And in the standard normal curve, Cornelius, that, actually, Betty rocks. Dawn, hey. What is the mean in the standard normal curve? You said it before?
0.
0, right. So when the mean is 0, that's one marking of the standard normal curve. Okay? The next one about the standard normal curve, do you agree that normally in the normal curve, each increment is one standard deviation? Remember that? Jump by standard deviation. 1 standard deviation, 2, 3, 4. Now, in standard normal curve, besides the mean being 0, standard deviation is, it's on your paper, you want to tell me?
1.
Standard deviation is 1.
Deviation is 1.
So, you jump by standard deviation. So what would this be if it's not 1?
-1.
-1.
It's like z-squared.
Exactly. That's the next thing we're saying. 2, 3, standard deviation. So -2, -3. So isn't it true that data and z-score have what relationship in this case? They're the same. They're the same. So imagine a normal curve that had a mean of 0 and a standard deviation of 1. That data actually equals the z-score. So these are z-score and their data. So that's the marking of a standard normal curve. Okay, so we're going to actually go in and experiment with it. So the mean is 0. We talked about it. Standard deviation is 1. There it is marked for you. And the total area under the curve is 1. Do you agree that this under the curve, all this stuff, is 100% of the population? 100% of the population. What percent of the population is to the left of my beautifully gloved hand? 50%, right? Let me ask you this now, leading question. What is the probability or the chance that data will be at 0 or less? What percent chance is there that a data item will be at 0 or less? 50%, right? So not only is this the 50th percentile, there's also a 50% probability that you'll actually be here or less, okay? And you remember that each of these is 34% on either side. So then if this is 50% up to here, 34% up to 1, what's the probability of being 1 or less? 84. 84, right? So this is just getting us acquainted. Again, actually later in the notes, you'll see the notes are there. It'll give you a chance to do that. But it's going to get more intricate now. So we have a table near the back of the book which relates z-scores with the area under the curve. So basically, z-score of 0, we talked about it. I'm going to match it to my finger. There it is. Z-score of 0, 50% area. Z-score of 0, 50% area. Well, what about z-score of like, here, let's do an example. Z-score of 1.27. Do you agree that z-score of 1.27 is right here? right there. What is the area to the left of my finger? Roughly? Yes?
Oh, to the left? Like
Yes,
all
to
the
the
way?
left.
Oh.
Is it the majority or the minority? Yes,
Majority.
it is the majority. Do you agree that most of the area under the curve is to the left of my finger?
Yeah.
Right. So, good guess. What was 1 again?
When I last was about 88.
It was
so-
84.
Oh, 84.
Oh, so you're, okay, yeah. This was
So-
84.
So then it would be 85.1.
Maybe 85-ish. Good job. It's around that. It's around that. So there's a table in the back of the book that helps us do that. This is an example from your notes. Let's try an example. What is the probability associated with z-score of 1.27? Note the standard normal curve shows cumulative areas from the left. So let's talk about it. Here's your normal curve. Do a quick one here. This is 0. This is 1. So 1.27 will be right around here. And we want the area to the left of this. And we're going to look it up at a table. Okay? 1.27.
Can we
I
do-
have, sorry?
can we do probability? I forgot the proportions. Like 1 is
Bless
to
you.
84.
Bless you.
Birthday bless you.
I don't know what I'm throwing something at you.
Can we
What?
set up a proportion and say 1 is to 84 as 1.27 is to x? Would that work?
Good guess. We can't because the amount of population in here is varying as you leave the as you approach the extremes. So it's not a linear progression,
Okay.
right? Like the difference in the area between 0 to 0.5 is different in the area from 0.5 to 1.
Oh, okay.
Does that make sense?
Yeah.
So it's actually straight out of a table. It's in your book, but I have it here conveniently for us. Not Rocky. Thank you, sir, for that. Okay. So at first, this table looks intimidating, but we'll teach you how it works, okay? This is the standard normal curve, cumulative or total area from the left. Okay, from the left, we want, this is all the area from the left measuring z-scores negative. So what's our z-score that we want? 1.27. So scrolling, scrolling, scrolling. Here it is, positive z-scores. Originally, you saw here negative z-scores. So positive z-scores, 1.27. Let's see if we can find it. Here it is.
Would you round to 1.3?
No, because I'll show you what that means. This is the tenths digits right here. So this is 1.2,
Oh.
and this is the hundredths digits.
Oh.
Once you learn how to read it. So this is the z-score of 1.20.
Oh.
This is the z-score of 1.21. This is the z-score of 1.22.
Oh, it's just so they don't have a big chart of 1.2, 1.2.
Right,
going
right.
through.
Yeah, so they aggregated it into a table. So 1.27, I'm going to circle it. 1.27, right here. So a z-score of 1.2, what is 1.2 plus 0.07? 1.27, good. And that z-score is 0.8980. So in fact, peaches and cream, remember when you said 88?
Yeah.
Match my outfit. Remember when you said 88? Actually, pretty close, it's 89. So 89% of the population resides to the left of z-score 1.27. Can we actually have someone say that for us? While I get this set up, I'm going to format it. Okay, so area equals 0.8980. Volunteer to put this in a complete sentence. I'll start it off. There is an area
Of 0.8980 left of
1 point.
left to the z-score of 1.27.
Very good. Now someone else to do the same thing using the word probability. There is an 89 track.
There is an 89.80 or 89% chance
Mm-hmm.
that you will like fall, I guess.
Fall, nice. Fall within
Within the z-score of 1.27.
or to the left of it. Or to the left of it, right. There's an 89% chance or 89% probability that you will be here or to the left. Fair? Yes.
Even though we don't round the z-score, because it's 0.898, would
Yeah.
you accept rounding to 90%, or would you
Generally,
stick to
yeah.
89.8%?
Yeah, and the purpose fair question. In the purpose of our class, I'm not going to like mandate tenths and hundredths and thousandths.
Okay.
If you get 0.89, I'm with you.
Okay.
Or 0.9, yeah. You get 0.9, I'm with you. That's very close, isn't it? Okay? But calculator will give it to us exact, so no sweat. Giving it away! Giving it away! Okay, over here. Hey. That's where they took it from. Good job. Do you like my socks? Nice. Hot step. You do that in practice?
Oh my God.
Yeah. Hot step. Hot step. Ooh, tired.
That water bottle is great.
What's up?
I'm good.
Okay, anyone? Anyone? No? It's just so hot. Oh, man. That was nice.
Oh,
I can't return it.
Yeah, right? I don't want to anymore. Okay. Assuming, ooh, I taste yum. Vanilla? Okay. Assuming a normal distribution, if the mean reading is 0 degrees Celsius, so this is a thermometer, okay? We're talking about a thermometer. Do you agree that if you're testing, here, let's go back to blue here. Please, blue? It didn't work. Okay. All right, tapped it again. Okay. So suppose this is how thermometer manufacturers actually operate. They build their thermometer and they verify that the temperature in the room is 0 degrees. They have it with thermometers at work. They have a test room with thermometers at 0 degrees. Then they take their new thermometers and they go in and they test the temperature. What do they hope that their thermometer says? 0. They hope that their new thermometers read 0. Okay? So on average, those new thermometers, when tested at 0 degrees, read 0 degrees. However, some thermometers need to be tweaked and worked and stuff. So the mean of a thermometer tested at 0, see, the mean reading is 0, but the standard deviation is 1. On average, the thermometers are wrong by 1 degree in either direction. Standard deviation 1, standard deviation 1. We called it S before. Same thing. These are both the same. So on average, they're wrong. So this is how it works. Assuming a normal distribution, you'll get into it, okay? You'll get into it. If the mean reading is 0 and the standard deviation of the readings is 1, what's the probability the freezing point of water will read 1.27 or less? So here's 1.27. Back to you, Don. 1.27 not only is the reading of the thermometer, but it's the what in this case? Standard normal curve. Go ahead.
Didn't you just give the answer?
1.27 is not only degrees, but it's also...
standard.
Try again.
What?
Yeah.
1.27 is not only the reading of the degrees, it's also the what of this curve.
Standard
The z-score?
The z-score. The standard deviation is 1. Standard deviation is 1. Maybe I didn't phrase the question. Okay? Standard deviation is 1. This is a z-score because if the standard deviation is 1 and the mean is 0, this is a standard normal curve. Question, please.
Wouldn't it just be the same as the other one before? So
Yeah.
wouldn't it,
It's the same answer.
yeah.
It's applied to real world now. Very good. So now once we identified that the z-score is 1.27, can you phrase the answer?
There is there's an 89.8% chance
Mhm.
that you have a 1.27 or
Yeah, so 1.27,
1.27.
at most
Or not at
1.27.
most.
At most 1.27. There's an 89% probability that when you test the thermometer at freezing, your thermometer will actually wrongly read 1.27 or something less than that. Okay? So there's a lot of chance that it'll be 1.27 or less. Okay? Questions in process? Questions on that? A lot of these standard normal curve problems involve temperature because it's a very easy example. So put it down. Z-score 1.23. What's the probability of selecting a thermometer that shows the freezing point of water as above 1.23 or negative 1.23? Here's 0. Where's the negative 1.23? To the left, right? all right, to the left, negative 1.23. And what area is it asking for? Which direction? Read it out. Yes, to the right. How do you know?
Above.
Above, right. So what is this area it's asking?
The same.
Sorry?
The same.
Good guess. If it was 1.27 negative,
Oh, I thought it was.
it would be.
Okay.
Good job.
So really close.
Very close.
Yeah.
Very close. That's a really good point. Is it true that the normal curve is symmetric?
Mm-hmm.
Right on. So negative 1.27 to the right. Same area as?
It's gonna be another 0.8 something.
Yeah, I'm with you. So let's actually go ahead and look at the table. We're going to look at, there's a couple ways to do this actually. So, you want to do negative z-score? Negative 1.23. Here it comes.
That's okay.
Negative z-score, negative 1. I know I passed it.
I see it.
I want to try to get the top. Almost. Just go a little more. A little more. Okay, well, what's the column we want? This one. So we want this column. That'll help us.
Yeah, no.
That's great. Negative 1.23. Do we see it?
Yeah.
What is the area to the left?
It's like 0.109.
Yes, here it is. Oh, that happened. Remember when that happens? Now here's the thing.
They're looking for the right.
They're looking for the right. How do we use it? Go ahead. Yes.
Like I'm
yes.
thinking if you have 100 and then minus that from 100.
Very good. So I know you mean 100%
Yeah, 100%.
is
But then,
equivalent to what number?
1. So you just have 1 minus.
I love when
Versus the
students use the
decimal.
word just. Yes. It's just 1 minus this.
Okay.
Right on. So this, again, the table, it says very clearly throughout the table that every value that you're given is to the left. See this? Cumulative area to the left of your z-score. So they gave us a z-score of 0.1093. Can you subtract it from 1. Bravo. Can I line it up again? There it is. One more. Whatever. Up. I'm being too ambitious. Negative. Or 1.10. Right here. 0.1093 is this area. So what is the area to the right then?
Everything else.
Yes.
89.07.
89.7. 1093 equals 0.897.
So it's like the same thing.
70.
0, 7.
07, thank you. 7907. Bless your soul.
So the probability or percentage is still about the same. Because the other one was 89,
Yeah,
89.8. This
yeah,
one's
she called it. It's very close, definitely. To be exact, 0.8907.
This one's closer to 89, but the other one's closer to 90.
Yes, you're right. This one's closer to 89, the other one's closer to 90. Because it was further away, wasn't it? 1.27. Questions on process? We're going to go to our next page. Okay. Doing great, everyone. Okay. Assuming same parameters as above, mean is 0, standard deviation 1. What is the probability a random thermometer shows the freezing point of water is between -2 and 1.5? So for you guys to pick this up right away is pretty awesome. It's a lot to do. Here's 0. So where's -2? Z-score? Yeah, to the left here, -2. And 1.5, here it is. And what area are they looking for, or probability?
Between.
Between. May I shade them?
Yes, you may.
It's my shade dance. Or shady dance.
I had to do that in the play.
So,
Do a little dance.
oh, is that what, through the metal detector? It's a good idea. You should do that. That'd be fun. Did you say at the airport?
No, I said in the play.
Oh, in the plane. I thought you said on the plane. Oh, you do that on the
You
plane?
do a whole dance in the airport. Yeah, I walk with a pineapple. Like that.
Oh, cool. I can't wait. Jan 26 through 30. Awesome.
Be there or be square.
Yeah. So there. What is the area of between these two z-scores? How do we do it? Suggestions? Is my band like totally jacked up now? Is it
The
okay?
tag is just like.
The tag is just hanging out. That's okay. I love my brands. I'm a brandaholic. So, how do we get those areas? Using the z-score table.
Better.
Yeah, okay.
What?
What do we do? Yes?
You can calculate the area to the right of -2 and
Okay.
subtract it by the area to the right of 1.5.
Nice. Why not find the area to the left and left? Because that's what the table gives us.
Oh yeah.
Is that the same idea? Good job. Because the table is associated with area to the left, we can get both of those easily. So we have 1.5, right? These are negative. Let's go up here to positive. Nope, negatives first. Okay, 1.5, 1.50, 1.50. Is that it?
Yeah.
0.9332 is the area to the left of 0.93 of, what'd you say?
That's high.
It's high, it's very high.
May I
Yeah.
ask you a question?
Please ask, always.
So on that graphic,
Oh, I'm not sure. Yeah.
um,
Yeah?
so you see the top where it goes 0.00, 0.01.
Right.
How do you know which one?
These are the hundredths place.
But how do you know which one to look at?
Good job. The question asks for z-score of 1.5.
Okay.
So 1.50.
What?
The z-score that they're asking for is 1.5 exactly. It even says 1.50 right here.
Yeah. No, but on that, when you're looking.
How do you know? Oh, good job. Yeah, okay, yeah, we have to learn how to read it.
How do I know which place one?
This is 1.5, right?
Yeah.
And then you add this hundredth
The
spot.
third
The
spot.
third best.
It's the third decimal. Yeah, this is 1.50. Bless you,
Oh,
1.5.
it's according to what they give you.
Yeah, the problem has 1.5. But do you agree, if I add 1.5 and 0.01, what's that number?
1.51.
1.51, bravo. We're not
I still
looking
don't get it.
why it adds up to 1.51?
No,
Or how to
I
read
get-
how to read the
which,
table.
Like which column to look at.
Well, in this case, good job. In
Because
this
before we
case,
looked at the third.
telling me thousands of people have the same question. Is this table, look at this table all together. Ah! Right?
Yeah.
Yay, math! No math! Right? So they look at this and this is crazy, okay? But now, we're asking for the area to the left of z-score 1.5. Is that true?
Yes.
So we're focusing on z-score of 1.5.
Yes.
Okay. In this table, z-score of 1.5 is 1.50.
Okay.
If the z-score is 1.51, that would be the area. If the z-score is
Is it
1.52,
whatever it ends in?
yeah.
Oh.
Yeah, this is the last
thought you
digit.
had-
I heard someone else say it's the last digit or something
Oh.
like that. Yeah.
Okay.
This is 1.53. This is 0.13 right here. 0.13.
Oh.
Cool?
Yeah.
So what does this z-score represent?
1.2.
1.21. This is the area of z-score 1.21. Very good. In this case, I'm glad you asked. 1.50.9332. Putting it down. So this area is 0.9332.
And you're
That's-
gonna give us that table on.
Absolutely, yeah. Yeah, I thought about having you memorize it, but I thought against it. So, just want to be fair, you know? You could also squirt water on yourself in the final. That'd be awesome. Like, okay. So, negatives are above. -2, area to the left of -2.
Wait, just 2, that's it?
-2, yes. Question?
Yeah. Can you reiterate what we're doing though?
Good job. We're finding the area between -2 and 1.5.
Oh.
And to do that, first you need to. How does the chart help us?
Good job. According to our chart, the area to the left of 1.5 is 0.93.
Oh.
Then we're going to get the area to the left of -2.
And then we're gonna subtract them.
Bravo. Then we're going to subtract them. Okay. Let's do it. Did someone get that before I turn the screen?
I did.
What was it?
0 point, or wait, no, it's like 0.0228.
I see it as well. 0.0228. Good job. 0.0228. Any questions about how to read the table? All right. 0.0228. Putting it down. 0.0228.
And it's like, it says area probability, so we say the probability you could still say 0.0228.
They're the same.
Okay.
Good job. This is the same answer. The area is the probability. The area is the probability. And what's that number? Did someone get it for us?
0.9104.
Good job. 0.9332 minus 0.0228. Say it again, please.
0.9104.
9104. Very good. Okay, you ready for the good news? The calculator does it for us. We don't have to look at the table. Don't have to look at the table. Saying that we don't have to look at the table. Okay. Our calculator lets us do it. You're welcome to look at the table, but you don't have to. Okay, let's look at it. In the graphing calculator, the function actually we'll show around your paper first. It's called normal CDF. It's under second bears. Normal CDF, and it asks for two inputs. The two inputs are the left z-score
And the right.
and the right z-score. So we can solve this problem now. Ready to go. Right now. Okay. Second bears. Normal CDF. Option 2. Pause for everyone to get caught up. Normal CDF. Second bears. Normal CDF. Hit. Okay, now. Many of the newer calculators has this functionality. If you don't have this functionality, you have exactly what you want to see. You'll just see normal CDF, and then it'll say, give it to me. Who has this? Raise your hand. Yeah, many of you have it. Good job. Who has what I have? Similar. Okay, good. So half is pretty much split. So normal CDF asks for left and right z-score. Left and right z-score. So you could actually put it in. What is our left z-score? -2. Doing it. -2. Enter. What is our right z-score? 1.5. You can do it as comma format for those of you that have the thing that I wrote. It's -2, comma 1.5.
Does that already subtract them?
It does.
Oh.
Area between. I know, I feel the same way. I feel it. I'm like slogging through the table. Ah! And then I look at this, I'm like, hallelujah. So my socks fell.
You're the same one.
Now I'm ready. Okay.
And lower and upper, you mean like grader wise, like.
Yeah, left and right z-score. Yeah. What is the mean in our case?
What?
0. Isn't the mean 0 for us?
Yeah.
Yeah. Is standard deviation 1 for us?
Yeah.
So it says paste all that in. So for you fancy calculator folks, oh, hit enter. No. Good job. Enter, 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 enter. Okay, so it put in some default values. This is the mean, this is the standard deviation. Don't worry about it. Don't worry about it. Just let it be as it is. Is that what we got?
Yeah.
Awesome. Awesome. Really good. Okay, moving on. Almost done, actually. Vandalism. Okay, scroll. Try the above problem we did. Finding a z-score from a known area. Okay. So, z-score of 0. What's the probability that you'll be to the left of 0? 50.5. Is that okay? What's the
Yeah.
probability?
No, I understand.
You're good.
I
You're
wasn't
good.
like thinking.
Okay. What's the z-score to the, or what's the probability or area to the left of -1?
40. Am I wrong?
Around? Do you agree that this is 34% based on our studies of normal curve?
Yeah.
So what's going to be here approximately?
13.5 plus
About 16.
16, about 16. Fear not, good friends. This is in the table too. You can get it in the table. It's right over here. Z-score of -1.
I see.
Z-score of -1. There's your 16 roughly. Okay? To the left of -1. Okay, moving on. Z-score of 1, probability of that? 84, very good. It's really, really crucial that you're able to not only read the table, use the calculator, but just know your basic normal curve increments. Yeah, these are both 34, 13.5s, and 2.4. We talked about that. Okay? Now using the table, what's the z-score? of 0.095. This is a preview. This is a big preview of where we're heading. Okay? We're talking about 95% of the population, or most. Would you agree that if you said something with 95% accuracy, then that's pretty accurate?
Yeah.
Yes. That's why this is a crucial number in statistics. What's the z-score for an area of 0.095? Give me an estimate. 95%?
2 point something.
2 point something. Very good. Very high. Very high. 2 point something.
Can you explain that again?
Yeah. If you're talking about an area of 0.95, that's 95% of the area,
As opposed to 100,
which is the full normal curve.
So that means that like that's like 1.
Yeah, the area of 1 would be 100%. Yes.
And an area of what would be 95?
0.95.
Oh.
You know what I'm going to do? Based on what you said, I'm going to turn this to 0.95 so that we start to get used to the decimals. 0.95. There it's area 0.95. And the z-score is going to be very high, like 2 something. Now, I challenge you to find it in the table. Where is an area of 0.95?
You pass.
It's in here. It's actually
Oh, an area?
an area of 0.95.
It's 1.7.
Yeah.
You can get closer.
Oh, 1.6.
Yeah, it's actually right here. You see this star?
Oh,
Many of the books actually mark it. It's such a common area. It happens so much in the field of statistics that they point it out to you. Okay? That's an area, yeah, a little snowflake, or a little like, wait, asterisk. Right. So this is around 1.6, 1.6 something. Let's follow the arrow. There it is, 1.645. 1.645. Or did I not? Yeah, 1.645. There it is. See that? I highlighted. 1.645 is an area of 0.95. Putting it down, 1.645 is the z-score. Questions? Okay. What are the z-scores for these two areas? Okay, now, oh, we did that already. Let's put that here. In other words, 95% of the thermometers will be less than or equal to what temperature? Can you answer that question? 95% of the thermometers will be less than or equal to what temperature?
1.6.
1.645. 1.645. Questions? You okay? You all right? How's the blue pencil working out? Working out. Love the blue pencil. All the shavings like filled the thing with blue. It's very cool.
Did you know they bend?
Oh, they bend. Wow, I didn't know
Don't
that.
bend them that much.
Don't bend them too much.
Yeah.
Mine doesn't bend.
Okay.
Let's do this.
I was trying.
Let's find the temperatures separating the bottom 2.5 and the top 2.5. The bottom 2.5 and the top 2.5. Here it comes.
What do you mean bottom and top?
2.5% and 2.5%. Here it is. Let's go here. This is 0.025 area. And this is 0.025 area.
negative.
What are the z-scores? That's the area. That's the area, right? So yeah, this will be a negative z-score.
But it's
And this will be a positive z-score.
Right.
Remember what you said before? Can you tell me the relationship between this z-score and this z-score? It's not -3 or whatever. But can you tell me the relationship?
Because of the symmetry?
Yes, because of the symmetry. What's the relationship?
It's symmetrical.
Right.
So, I mean, whatever's true on that side is true on that
So what if, suppose this was 2. What would this z-score be?
Negative 2.
-2, yes. Because the area is the same to the right and to the left. Yes?
I follow.
Do you agree that the z-score here, let's suppose the z-score here is the z-score associated with 2.5% of the population to the right?
Okay.
Okay?
That's okay.
Let's get it. Let's get it. 2.5 to the right is in our table. Here we go. No? Okay. Area of 2.5. I'll actually give it to you. It's coming up. Here, we'll find it. Where is an area of 2.5 to the left? Or 2.5 to the right? 0.025. Where?
Where the star is.
Star is? That's 0.005.
Okay.
Let's try again. 0.02. There it is. See it?
Yeah.
So this is an area of what to which direction?
It's an area of 0.2.
0.025.
0.025 to the left.
Yes, an area of 0.025 to the left. Stay with us. 0.025 to the left area has what z-score with it? Sherman White? Go ahead. What z-score is associated with this area?
Negative
Yes?
1.9.
1.9?
6.
Negative 1.96. Negative 1.96. Put it down again. Oh, it's actually on our board here. Negative 1.96 is the z-score. So now back to your question. If the z-score associated with an area of 2.5 or 2.5%, 0.025, is negative 1.96 here, what do you think the z-score?
Positive.
What positive? Because of what we said before, symmetry. Would you like to do this on calculator now too? I see eyes like, oh, I can't handle more info.
Wait.
I can't.
What
Yeah.
is the 0.975?
Oh, to wake you up. 0.975, well, if this is an area of 0.025, wouldn't everything to the left be 0.975?
Yeah, so what's the z-score for also 1.96? Is that what you were saying?
1.96? Well, yeah, the area to the left of 1.96 is 97.5.
Okay.
97.5. It's everything that 2.5 is not.
I
Okay.
guess.
Let's put it down. I'll give you the calculator.
But that's when they specifically say like the z-score of 0.025, you have to realize that it's to the left. Like,
Yes. Yeah, let's talk about it. When tested at freezing, 2.5% thermometer readings will be less than or equal to how many degrees? Can you tell us?
1.96.
Less
No.
than. So it's on
Oh.
the left one. You want to see the picture? It helps.
Yeah.
The picture helps. I'm glad you're trying.
Well,
2.5% of the thermometers will be less than or less than this.
Oh.
What temperature is that?
it's like -3. Oh no, it's negative 1.96.
Yeah, negative 1.96. I realize I'm drinking sink water. Yum.
Maybe that's why it tastes like vanilla.
Yeah. Why it tastes so what?
Before you were like vanilla.
Oh yeah, let's vanilla. Let's flavor our water. And 2.5% of thermometers be greater than or equal to what temperature?
1.9.
Yeah, 1.96. 2.5% of thermometers will be here or more. Here or more. That's 1.96. You okay in the back, JS?
Yeah.
Okay, you sure?
Yeah, I'm good.
All right.
Appreciate that.
Putting it down. 1.96. Meaning 95% of the thermometer readings will be between what degrees? Do you agree, back to the thing? Do you agree if this is 2.5 and this is 2.5, how much of the area is between?
95.
95. You're good at this.
So between 0.025 and your 0.25.
Well, yeah, I'm talking about these
0.0.
areas. These are the areas. So we can put them
Oh,
down.
those are the, so it's the same answer as before then.
Yeah. So but how much is between?
So it's from a z-score of negative 1.96
So
through
1.9.
1.9.
How much area is that?
95%.
Good job.
So it's just negative 1.96 and 1.96.
The area between them is 0.95. And remember, we know how to do that on the calculator. You can do it right now. Calculating the area between negative 1.96 and 1.96, I'd recommend doing second enter. You get the same thing back, and then you just scroll through here. You do negative 1.96 to 1.96. Here we go. 1.96, comma, 1.96. Enter. 95%, 95 probability. All right. There's one more calculator function I want to show you, and then we're done. Inverse norm. It's the last one. Okay. Total area to the left of the z-score. So this in the calculator right here will give you the area to the left. Oh, excuse me. It'll give you the z-score. Yeah, it'll give you the area. Sorry. Yeah. No, it'll give you the z-score. Sorry, I was thinking a second. I'll show you one more time in the calc. In norm. Sorry. Just want to get it perfect, you know. There you go. Inverse norm, area to the left, gives you a z-score. Can you do two calculations with me and then we're through? Okay. Inverse norm area. So if we did this one, there we go. What's the area to the left here?
0.025.
0.025. Area equals 0.025. So if we did inverse norm of this value, second verse, actually let's clear this. Second verse, notice you see inverse norm, option 3. Area to the left, 0.025. What do we expect to see? What z-score? What z-score has an area 0.025 to the left? Negative 1.96. So this asks you for area to the left, and it will give you the z-score associated with that. Again, asks you for area, gives you the z-score. Okay, symmetry friend. What would be positive 1.96? What area associated here? Last question of the day.
Asking me?
Yeah, I'm asking you.
Wait, what? I got lost in this last part.
Okay, this calculator function.
Is it just the opposite of what we did before?
Sort of, yes.
So before, on the chart, before we're looking, we're given, no, not that, the whole, the number.
Oh, the number chart, okay. This thing? The table?
The table. We don't even need
We don't need the table. We don't
No,
need
no,
the
no.
table. Let's look at the normal curve. That's what we want. Look at the normal curve. What's the area associated to the left of the hand?
You mean everything to the
Everything to the left of this. How much area is that?
95 plus 0.
Yes, 95.95 plus 0.025.
Yeah.
What is that?
No.
Can someone help her?
0.975.
0.975. So let's put that in blue. This area is 0.975. So if I wanted to get the z-score associated with area to the left of 0.975, I use this calculator function called inverse norm. Observe. This gave us the z-score associated with area to the left of 0.025. Now let's get the z-score associated with the area to the left being, tell us.
0.9, yeah, sorry.
What do we expect this to be? This is your question.
What do you mean?
What's the z-score associated with this?
Over 2,
Can I look at and show you again?
isn't it? 1.96.
It's 1.96. Do you know why?
But what are we doing differently? We already knew that.
We already knew that. We're proving how to get in the calculator. Yeah, we already knew that. This is 95 or 97.5 all the way through, 1.96. This is 0.025, negative 1.96. Symmetrically, they're the same amount off the extremes. They're the same amount off the extremes. Let's put that down, and we should get 1.96. And we hit enter. Okay, same thing. What are the questions before we conclude? Any concerns?
Can we try another one of this next class? This was like.
Yeah, you have a lot of homework to do. There's a lot of this. What's the z-score of this? What's the z-score of that? What's the area of this? What's the area of that? So actually try a lot of practice, okay? So the more you practice, the better you'll get. But seriously, thank you all. Everyone, let's do it. Let's do it like, yeah, woo!
Yay Math.
You can actually hit that. Bye.